Welcome to the conclusion video for New Electromagnetism V5. Now, this isn't the end of New Electromagnetism. This is only the end of the beginning. There's a lot more to go, and we'll discuss that toward the end of this video. This is the 13th video of New Electromagnetism V5, and New Electromagnetism is the 4th book of Ethereal Mechanics. This is being presented to Patreon folks on 8 September, and it will be made a premiere on YouTube on 3 October 2024. So what we're going to cover in this is we're going to give you a synopsis of what was covered in the video series, what still needs to be done, including what supplemental papers and experimental builds are in the pipeline. And then in the end, we're going to explain why we're taking a break from NEV5 to take a segue into cosmology. This all fits into the big picture of ethereal mechanics, which I'll show you at the end. Okay. In the previous video series, EM03, which is electrogravity, we developed the Ampere matrix field, also known as the Pretonic field model. This is a radiation field model from a Preton, and it is a matrix field. It is not a vector field, it's a matrix field. So this diagram down here is a little bit underrepresentative of how we can show a matrix field. It's notional only. But from this basic Pretonic field, I'm going to show you that all of new electromagnetism, including the force of gravity, come from this model. Okay, so the way we began that in electrogravity is we take the time derivative of this and then multiply it by a target charge to get a force on the target charge. From this time derivative, we end up with these two components. One is identified as a magnetic force, and the other one's identified as the inertial force. And the inertial force has been with new electromagnetism from the beginning. We knew it as new induction, and it was found by experiment. This is the first time we're showing all of these things derived from one single underlying force. And it was, in fact, the many years of looking at this and saying, you know what, there looks like there's something underlying. The problem that was obscuring it is I was trying to use classical magnetism, which does not have enough representation. And, well, you can watch that story on your own. Essentially, we have these two forces come out of the time derivative of the Pretonic field. Okay, then, if we take our model of matter is pretons spinning, counter-spinning each other, and they're spinning much, much faster than the speed of light. But because they're spinning up the medium, they're only spinning at the speed of light relative to the medium. Okay, and this is how we reconcile a lot of the problems with the varying speeds. And so the pretons are spinning up the medium, and this is essentially hellfire. This is starfire. This is essentially starfire. If you make this unstable, you release nuclear energy. So, from that model of matter, if you take two models of matter, which these would be two electrons, and then you compute the magnetic force and the inertial forces between them at all the different orientations, you end up with the Coulomb model, or the electric force model. Okay, the difference being now is because it is synthesized by matter, it is subject to what classical theorists would call time dilation, but what we call in ethereal mechanics, we call it process dilation, or material process dilation. Okay, these are not subject to time dilation because they're pure. They're not part of the model of matter. Okay, now there are a lot of other very complex interactions between these, okay, but they happen at very small distances. And so what this model here is what's known as the far field. This is what remains after you go a very, very far distance away, where distance is much, much greater than the radius of these systems. And this is the predominant force that remains at far distances from these systems. And that's what we're looking for in new electromagnetism. We're looking for benchtop equations that electrical engineers can use. If you're going to be looking at the subatomic level, you have to consider all the forces in there. There's a lot of interactions going on that are a whole video series on their own. So right now we're concentrating on these forces here, the electric force, the magnetic force, and the inertial force. And these are all in natural units of square amperes. If we multiply these by Km, which is mu over 4 pi, we convert these to legacy force, which is newtons, which is kilogram meters per second squared. And we do this often mainly because our instruments still read in the legacy units. But it's a lot easier to do the derivations when you don't have all these constants hanging around. We have absolutely no constants. And that is a requirement of the 24th rule of acquisition, that a theory of everything should not have arbitrary constants of relation. Okay, we can have arbitrary constants like the speed of light, but those are measured values. They're not arbitrary. These values, mu over 4 pi, they're completely arbitrary. But we'll get more into that when you view the 24th rule of acquisition video. Okay, now, when we started the new Electromagnetism V5 video series, we started before we had all of the paper written. And so we ended up having 2 introduction videos. And let me explain the hierarchy of this. So what happened is I started making the videos, and then we got to electrokinematics and found a whole bunch of new stuff that improved new electromagnetism, and mostly definitions. And so what I did is said, okay, we got to reissue these first videos in the B subscript to let everybody know we got a more improved version. Now these 2 are still good. This one uses original introductions, but it has a lot of good stuff in it. But this is the new one, which shows part of this new stuff, which was called the planar inductor techniques, which allow us to do analytical solutions for solid modeling, and it's much easier than anything we've had before. And it allowed us to derive the effects of a linear piece of wire to the point where we have an experiment, the latex experiment, which shows the classical theory, the donut-shaped field of classical theory is not sufficient to fully describe the magnetic field. And it shows that the spherical field of ethereal mechanics is far superior. Okay, so we redid those videos, and we kind of have these 2 that work side by side here. Because in how inductors work was kind of folded into this. So you can still watch these 2. These 2 don't matter because they use the old nomenclature, and they are redone with the new nomenclature for the version 5.1 of the paper. Once we get to 5 and beyond, they're the same one. There's no separation. But for these, I am using the thumbnail that has the B on it. So after 5, whether it's a B or not doesn't matter. There's only one, because everything is 5.1 after that. So if I'm using the thumbnail that has the B, that's fine. Okay, so you have this guy which shows how inductors work, and this guy which has expanded definitions, and it has a small synopsis of the leading expert fallacy, which is the new rule of acquisition number 37. We're up to 37 now. Okay, and then you go on to the 3rd video, which does the introduction to wire fragment modeling, derivation of fragment to point models, which is the basis for all other magnetic derivations. And I give an interesting show how the illusion of classical magnetism gives you that flux line model. So it's a very interesting video. And from here, we developed one of our first models, which is the inertial VIM, which is basically the new induction model in wire fragment form. Okay, then we get on to video number 4, where we develop the magnetic interfragmentary force model, and we have an experimental validation. That gives us this model here. Then we go into 5, we develop the thing called VIM to replace EMF. That's part of the improvement for the 5.1 paper. And here I have a bonus for all the physicists out there. I explain how you could correct Maxwell's equation to obtain a better model of light that is in quadrature and does not violate the laws of physics, specifically conservation of energy. Okay, so with that said, that we go on to the interfragmentary VIM. This is, you have 2 loops of wire that are in motion. How do they electromagnetically couple to each other? And that gives us interfragmentary VIM right here. And then we have the Coriolis charge motion, where if you have a current, which could be an edge current of a magnet or another loop of wire that's rotating, you're going to have Coriolis forces. And the green here is the magnetic force model. The blue is the Coriolis inertial model. And you add the green and the blue together to get the black. And the red is the oscilloscope trace of the measured experiment. We are not considering halo effects with this because they're very small for systems. They really don't affect systems like this. Halo effects only are very close in effects. And this gives us the Coriolis inertial VIM to add to our list of models which are growing. Then in video 8, we show the centripetal charge motion. Okay, and what you see here is you see the EGX, the electrogravitic experiment, where at the corners we see a force, which is the force of the charges accelerating around the corners of the wire. And this gives us the centripetal inertial VIM junction to fragment and fragment to fragment. And then we developed the Venturi charge motion. And on this one, the square coil is underneath the sensor film. That's why you can't see it. So the sensor film is between the square magnet, which is being juiced up with 100 amps, and the pickup coil, which is centered over a corner. Okay, then we have the Venturi charge motion, where if you have a tapered section of copper, the charges are going to accelerate. And we can see that as this taper. Down here, where the charges have to go around the corner, we have the electrogravitic effect. Okay, and then here's our pickup coil. So in this picture here, the sensor film is between the source coil and the pickup coil. Okay, after this video, we add the Venturi inertial VIM. Now, I realize I should have developed a fragment-to-fragment version, so we're going to make that something to be done in the 5.2 paper. It's very easy. You can just follow the derivation and just do it's not a hard derivation to do. Okay, then in video number 10, we have the advanced conductor model, which shows you all the effects you have to consider at the corners, at the edges, at the whatever, for a conductor model, and the different methods of modeling conductors, whether it be solid wire modeling or fragmentary modeling, and which is best to use under which circumstances. Okay, and then on to 11, we have the advanced model of magnets, and we also introduce the method of images for magnetic fields. Okay, there is, in classical theory, has a method of images for the Coulomb model, and exclusive to ethereal mechanics is a method of images for magnetic fields. And we also have how the magnetic viewing film actually works. Then in video number 12, we have a supplement for how magnetic viewing film works. And then we also introduce a Hall effect derivation from V5. Now, what I did in this, which caused me to learn something new when I was developing this final video that you're watching right now, is what we did in that video is we took all the components of this that are responsible for the magnetic field and just put the scalar value here. Because the classical Hall effect, we can see the parts that are responsible for the Hall effect and the parts responsible for the magnetic field. And I decided, because the version we have is limited to circular wires, and it's not in fragmentary form, so I can't put it into physics 2. So we really need a fragmentary form of the Hall effect. So what I did is I followed this logic here. I took out the components here that are responsible for the magnetic field, but kept it, instead of going scalar, I kept it in matrix form. And this is very interesting, because if we compare this to the donut-shaped field model from classical theory, remember I said this cannot be the model of a magnetic field because according to the latex experiment, there's not enough information here to fully account for the effects of the wires in the latex experiment. Okay, and this is what, if you pull out the same component, it looks identical to this, except instead of having a donut-shaped field as given by the cross product, we have a matrix field, which is spherical. And this gives us the degrees of freedom necessary to get the correct answers for the latex experiment. Okay, now what's even more interesting is we can write this in natural units, and our magnetic field comes out to amperes per meter. And then if we take out the integral, it's amperes per square meter. Okay, from there, going the other way around now, we can develop the fragmentary Hall, and this will be included in the 5.2 paper. This is what it looks like if you go through the derivation. And again, we can replace this component here and the S with the dB later if we want to. And to make it more of a general expression, we're going to leave that for the 5.2 paper to figure out. But now that we have a fragmentary form, we can put this into the Physics 2 software and actually do modeling on a Hall junction. Now, Now, this derivation assumes that any source component or source fragment of wire is significantly far away from the Hall junction. Okay, so be careful. It's got limitations on use here. So now we add the Venturi and the Hall effect to our thing. And you see it's getting pretty busy. Oh, we're also adding the new magnetic field expression. That will also be in the version 5.2 paper. So a very interesting thing happened. I took some time to analyze the electrogravitic experiment and reviewing the stuff we did for new electromagnetism V3. And in fact, new electromagnetism V5 does in fact agree with NeV3 that there is a canceling force there. The difference is NeV5 shows that it's not perfectly canceling, which is exactly what we're looking for. In fact, the two different, the gravitic and the antigravitic fields have locations where they're vastly different. And so part of the next amount of work is find out where they're different and then start moving our coil to the place where they're very different so we can get better experimental results that we can turn back into material properties to update the material properties. Okay, and then when I put the antigravitic effect into the simulation, it is not perfectly equal and opposite, which is exactly what we were seeing on the scope. It's nearly equal and opposite. I actually had to turn the scope up, and then even after turning the scope up, it was only off by a couple of pixels. That's exactly what we're seeing here. Now, I have a handle on the other anomaly that was there. I think the other anomaly might be the magnetic response of the table, because the magnetic responses of ferromagnetic materials is not as fast as our scope traces are, and that might explain the 2 millisecond delay. We got to track that down. Okay, so now what we're going to do is we're going to add the antigravitic effect as I believe it to be right now. Okay, now I'm not going to show this to the public yet. This is only visible. This area down here is only going to be visible to the Patreon published version. And what the more important thing that this shows is that there's 2 other weaker forces out there. That is the most important point of this realization. That's what we've been looking for, is a signature that there are other forces. That's why in the beginning I told the Patreon members that if the electrogravitic experiment gives me a 0 result, that would be better, because that means there's other forces out there. But we got the best of both worlds. We got the antigravitic effect that almost cancels the gravitic effect, which is more fantastic than the 2 cases I had before, because now we have an indicator of where these other forces are, and they're going to be tiny forces. Oh, and just so that people haven't followed the video series, anything below this line are very tiny forces. These are going to be tinier even still. And the way you can tell if they're tiny, if there's a QSPM or a QTM3 in the denominator here, that indicates that these are very tiny forces. So for most engineering applications, you're going to use the stuff on the top up here. And you can pretty much ignore these. Okay, now remember, going back to the beginning, all of this stuff is derived from one single Pretonic field. Now I moved all these stuff down here. So these are going to be released in the version 5.2 paper, and there'll be supplemental videos at that time for these items. But again, like I said, all of this is derived from a single unified field. This is the precursor to all of these field effects. Okay, but again, we're far from being done. We still have to resolve the zinc anomaly, and that's going to be the Hall Z experiment. We have to get the final issues with the A-type viewing film worked out. We still have the nichrome anomaly that's going to be resolved with the EGX experiment. We have other supplements, advanced method of images for the different types of materials, a model of magnets, because what I've shown in this video series is basically an introduction with improved viewing film models. Planar inductor model, have not released that to anybody yet, and you're going to have to make a physics how-to video series for those people that are going to have access to the Physics 2 software. So now I said I'm taking a break from new electromagnetism to produce the 5th paper of ethereal mechanics cosmology. And once cosmology is done, we're returning to focus on NEV5 before plunging into Ethonics. So explain why I need to take the break. Let me show you the big picture of ethereal mechanics. Ethereal mechanics goes from the very tiny Ethonics, this is the particles that make up the ether, to Pretonics, which is the precursor to all matter and fields. And we get the model of matter, new electromagnetism V5, and we're going up the scale. So we go from the very tiny to the very large. So this is going up. And you notice how we have little black circles here. Those little black circles means those are things that are anomalies we still have to resolve. Okay, in Ethonics, there's a lot of unknowns there for us. So this is our current level of how deep we've gone down the rabbit hole. And from here, we've been able to derive everything going forward. And these anomalies are the parts that we want to minimize, because then after we do that, we're going to take this model and go the other way and start clearing up these anomalies. That'll give us a better model for Pretonics that we're then going to take to the large scale and see if we can't wipe out more of these spots. Right now, we have a couple of things that are going to be resolved with the 5.2 paper. But what all of these anomalies here show us in these 3 seconds, there's a couple others, but each one of these has an anomaly. All 3 anomalies explain to us that there's another set of forces out there. And this guy is giving us a good footprint of what those forces look like, so we can reverse engineer them down to the Pretonic level to say, well, what do those look like? Once we have that, we can plunge with more confidence down the rabbit hole and move our line of what we know here and then reinvent everything going up and down. So the idea, like I'm trying to explain here, let me show you a picture that illustrates it. When you're painting a wall, you're going to have holes as you go up and down. And every time you go up and down, you're going to create more of the holes. And that's what we're attempting to do. That's why we're going to go into cosmology, fix the remaining problems of new electromagnetism V5 to improve our Pretonic model as best we can before we then dive into Ethonics. Because Ethonics here is the most important part. This is the part where we learn how to manipulate the ether directly. What's actually going on for all these fields, because right now we just have a matrix abstraction for the field. We don't really know how that is manifested in the actual medium. Okay, so that is the important point. This is the part we don't have a lot of information, but that's where the holy grail is. So that's why we want to make sure these are as anomaly free as possible, because that gives us the strongest jumping off point to dive into the rabbit hole. So that's what's going on here. Okay, this is the latest punch list for NEV5. These yellow spots here are all going to resolve each other when we get to the 5.2 paper. I'm very confident that that's going to happen right now. But until we do that, we still have to mark these as yellow, which means under investigation. Okay, so we're going to be honest to our anomalies, because remember, our anomalies are not something to be shied away from. They're things that we want to have, because they're going to tell us the parts that are missing so that we can have a better jumping off point into the ethereal rabbit hole. Okay, so we have to understand where our anomalies are. They're the most important points. They are the clues. Okay, we don't want to be like classical physicists that hide the anomalies and hide the errors and then say, oh yeah, I'm smart, we have no anomalies. People tell me Maxwell's equations are irrefutable. Well, obviously you don't use them. If you knew that they had anomalies, that's what told me that there's other stuff out there. It's because I found anomalies with classical theory. That's what started all of this. By ignoring the anomalies and thinking your shit don't stink, you're not going to make any progress. Again, I'm sorry. People call me angry. I'm not. I'm just frustrated. Okay, this is our release schedule. There's going to be no premiere October 10th for the YouTube folks out there because I need to catch up. I'm falling a little bit behind on the video production. I need to keep the Patreon members, trying to get them a release every week until we get through the cosmology stuff, and then I'm going to take a break. Don't know how long, a couple of weeks, take a vacation. It'll be a staycation working on ethereal mechanics, but just try to get myself away from video production for a week or two. Okay, so this is the premiere site for all the YouTube releases. Please sign up, hit the like buttons, blah, 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 all that stuff. This is the repository. Once the conclusion video that you're seeing right now is published to the premiere on Patreon, I'm going to update this link here so that all the videos will appear in the appropriate order here, so you can go down and check them with descriptions and all that. If you want to see the electrogravity stuff, you go into the Ethereal mechanics, and there's a button under there for electrogravity. That should all be there. If it's not, or if I don't have the paper, let me know. This is the blog site. Shout out to Sebastian for taking care of this. Again, if I can get enough Patreon members that I can do like Ethereal mechanics full time, I could put some killer time into it and also spend time here. And, you know, because my Patreon members know I'm very bad at responding to comments because I'm so busy. It's just a matter of time. I just don't have time. So this is the Patreon site. I would really respect if you could become a Patreon member. Again, you'll see the technology-related videos at least 4 weeks before the rest of the world. Some cases you'll see stuff years in advance, and in many other cases you'll see stuff that's never released to the public. So thank you. No more voodoo physics. I finally decided I should put a definition of voodoo physics according to the rules of acquisition. You are welcome to read that on your own. Thank you very much.